Hey, what's up YouTube? So in this video I'm going to be showing you guys my latest project. It's a portable Raspberry PI3 / handheld retro arcade system. And I've been working on this for a couple months now. I'm actually pretty excited about it. So today I'm just going to show you guys some of the features and give you a little demo. I'm not really going to get into too many specifics as far as the construction and the build is concerned, but I might eventually do a full write-up and put that up on my blog so you guys can check that out if you want. Alright, so let's go ahead and take a look. So at first glance, it's obviously not that attractive. It's kind of hacked together. I got JB Weld everywhere at the moment. And, you know, my speaker mesh holes are just kind of all over the place. I might sand this down and do like a screen bezel and a acrylic cover, make it look nice. But for now, it is what it is. It's actually not that bad. So for our screen, we've got a 5-inch HDMI LCD. It's made by a company called Waveshare. After doing some various configs and tweaks, I actually got it working really well. It's got a nice bright clear picture. For the controls on the front here, what I did, I just took two Gamegear PCBs, hacked them up and combined them to give me this nice 4-button layout. For the others, I just used some tactile switches that I had laying around, and they actually work quite well. So for peripherals, we got one external USB port here. Originally I planned to stack 2 of them, but I ran out of room, so I'm trying to figure that out right now. We've got a 3.5mm audio jack for external speakers or headphones if you'd rather use those. Otherwise, there's a pair of 4-ohm speakers on board for sound. And then over here we got a micro USB connector for power and charging. And up top, there's a power switch for turning the system on and off. This little red LED here on the front is for indicating battery health and status. And how that works is once it detects that the battery's starting to go low, it'll begin flashing at you once per second. If it's within a healthy range, it'll just be off completely. And if it's plugged in or charging, it'll flash a little faster, twice per second. If it's fully charged, it'll just be solid red. So that's the outside. Now I'm going to open it up and show you guys the internals, give you a little walkthrough of some of the various components, and after that we'll go ahead and boot it up. Alright, so I got it open here. First we'll take a look at the front panel. So obviously this is the Raspberry Pi. The screen is pretty much piggybacked onto the GPIOs, which is really convenient. HDMI connector is right here. I made my own standoffs for the screen. So everything in here is pretty much all modular, meaning that it's held in with screws pretty much, except for the speakers. They're hot glued in there. So it makes it really easy if I need to replace something or, you know, change a part out. Even the wires, they're actually not soldered right here. I can just go ahead and pull them off. They're using these little connectors. I desoldered my USB ports as well as my Ethernet to give me a little more breathing room. And obviously, since I have to wire things up to my USB ports. And then over here we've got a 64GB USB that's actually on board. I don't know if you guys can see it very well, but I got a female USB socket in there, and it's just hot glued to the back of the screen, just like the Teensy here. So all my buttons are wired to this Teensy, and its job is to handle all the input and send it to the Pi. And it also takes care of bounce, which is an anomaly that occurs in mechanical switches. So for example, if I press a button, it'll actually fool the system into thinking that it's multiple presses when in fact I only pressed it once. After I cleared that up, what I did is I have it monitoring the battery voltage constantly, and if it gets below a certain voltage, it tells me that it's dying by flashing my LED that's on the front there. One other feature is if you plug in the headphones, the Teensy will drive one of the pins on my amp Pi, so it'll shut the amp down. That way the speakers aren't still going when you plug your external audio in. Here's my buttons and my D-pad PCBs that I was talking about earlier. So I got a proto board holding the 2 sets of pads together so they're in line with my buttons. And same thing over here, I just got a single piece of a PCB, and then I soldered up my wires to the PCB, which connects to the Teensy. So that's pretty much the front panel. So we'll go ahead and take a look at the back now. Alright, so I went ahead and spun it around so you guys can get a look at the back here. So first of all, this is our power supply, this guy over here in the corner. I know you probably can't really see it, it's kind of buried under the wires there. It's known as a DC-DC booster converter module. It's made by a company that goes by the name of Adafruit. It's a Powerboost 1000C. Really awesome little board. So its job is to take the 3.7 volts provided by our batteries here and boost that up to 5.2 volt DC, which gives us enough juice to run all this stuff. It also has a load balance sharing circuit on board that'll actually let us run the system while it's plugged in, and it will charge the batteries at the same time. This is a 3.7 watt Class D stereo amplifier that's also made by Adafruit, and basically our Pi's audio signal is run through that, and then it provides us with two 3.7 watt stereo channels that drives these pair of 8 ohm speakers. All our audio is connected to this little jumper block here, which is pretty convenient. Over here we have our power distribution block. It's essentially just a couple rows of 2-pin headers. On this side you have all your ground connections, on this side you have all your 5-volt connections, which of course is provided by the Powerboost over here. And so that's how everything's getting power and ground. For batteries, at the moment I'm using these old pair of 3.7 volt lithium ion cells that I yanked out of an old laptop I had laying around, and the charge is maybe 2 hours tops, but I just ordered a new pair off of Amazon. Earlier I mentioned how the Teensy monitors the battery voltage. So it's this little guy over here, probably can't see it. It's two 300 ohm resistors that split the voltage up that it's getting from the battery. And the reason for that is if you just try to read the voltage right at the battery, it gives you kind of a wonky reading. It's not very accurate. It's like twice the voltage, a little more. So what I did was I routed everything over here to this little voltage divider circuit, and that actually splits the voltage reading up to a more accurate number. So that's pretty much it for the internals. I know it's a rat's nest, there's a lot of wires, but usually when something goes wrong I know right where to look because I've been staring at this now for a long time. Most of the time it's just one of the connectors popped off. I think one time I crushed a wire on accident when I was tightening the case up, so the ground connection got severed there. I was able to find it pretty easily and fix the issue. Closing it up's pretty simple. You know, I've already got it orientated in a way to where I just fold everything. The only thing is when I'm closing it on the bottom here by these standoffs, I gotta push some of the wires out of the way because you don't want to crush them. So after I do that, these guys here. So just a quick update, I went ahead and installed these new batteries I got off Amazon. There's some Revtronic 2600 milliampers an hour. I got 2 pairs for 30 bucks. So far I've already seen a huge improvement in both the battery life and the charge capacity. Moved my voltage divider circuit so it's closer to the battery, and I revised some of the wires, made them a little shorter. I noticed the Pi was getting a little warm. Not extremely hot, but I drilled some ventilation holes here. I don't know if it's going to help much. Alright, so I got it all closed up. Let's go ahead and boot it. I'm running a dual boot via Noobs, so I have both RetroPie and Libre ALEC on here, which is an open sourced Linux based media center OS. So this thing actually doubles as a media player as well. Let's go ahead and boot RetroPie. Alright, so we're here at the main menu. Here's all my systems. And I think that's going to pretty much do it for this video. If you guys have any questions or comments, feel free to drop them below. I'll probably just end it off with some gameplay. Thanks for watching. Feel free to like and subscribe. And until next time, peace.